This is a continuation of the Chapter 6 review, beginning with Problem 6. In Problem 6, we are told point D is the incenter of triangle LMN, and we need to find the value of x. So let's investigate the idea of incenter. An incenter is the point of concurrency of angle bisectors of a triangle. That means this angle and this angle are congruent, this and this are congruent, and this angle and this angle are congruent. Unfortunately, in this problem, that doesn't really help us. The other major factor in an incenter is the fact that the incenter is equidistant from all sides of the triangle. That means DT, DS, and DR are all congruent. And that makes our problem rather trivial, because in this case we know that all these sides are going to be the same, and since they're all the same and this is 5, DS has to be 5 and RD has to be 5. So our answer to our problem is simply x equals 5. And that's all there is to it. Now let's move on to Problem 7. In Problem 7, we're asked to find the centroid of the triangle with the given vertices. And the vertices of our triangle are negative 10, 3, negative 4, 5, negative 4, 1. So to save time, I've gone ahead and done that already. So let's bring that up. And here's our triangle. Now, a centroid. Centroid is the point of concurrency of the medians of a triangle. Now, what a median is, it's the segment, line, ray, from a vertex to the midpoint of the opposite side. From a vertex to the midpoint, from a vertex to the midpoint. Now, fortunately, we're only going to need to do this twice, because the point of concurrency of any two medians is going to give us the centroid. So we can take AC and BC. BC is an easy one because it's vertical, so finding that midpoint should be fairly straightforward. So let's go ahead and do that now. And we know that the x-coordinate of the midpoint is going to be negative 4, simply because both coordinates of B and C is negative 4. So we need to find the distance, the midpoint between 5 and 1. And so that's 5 plus 1 divided by 2, which is 3. Remember, midpoint is the average of the endpoints. In this case, the average of the y's, so it's 3. So we know that our midpoint, let's get a different color here, our midpoint is going to be right there. Okay. Now, we need to find the midpoint of AC, so we have to have the full 9 yards here. We're going to have to do the x's and the y. So we have negative 10 plus negative 4 over 2 and 3 plus 1 over 2. So negative 10 minus 4 is negative 14. So that's negative 14 divided by 2. And 4 divided by 2, which gives us negative 7 and 2. So negative 7, 2 is our midpoint. So let's go ahead and put that one in. So negative 7, 2. And there's our midpoint. Now, with a less straightforward problem, we would actually have to create equations of lines going from the vertex to the midpoint, vertex to the midpoint, and find out where they intersect. Fortunately, we have one here where both the y coordinates are on the same line. So that's all we really need to do, is to draw a segment from here through this point. And we can see that the centroid is going to be somewhere on this line. So wherever this line and that line intersect is going to be their target. So let's draw a segment this way through that point, and you can get a pretty clear idea that the target point is going to be right there. So we didn't really need to go and draw all those other things. So there is your centroid. And so your centroid then is at the point, so let's put it out here in that same color. Centroid is at -6, 3. And that's problem 7. Now on to problem 8. Problem 8 is another centroid problem. Here are our coordinates. So let's go ahead and bring that graph up. And so here we go. D is 2, -8. E is 2, -2, and F is 8, -2. This is an even more straightforward problem because we have a horizontal and a vertical segment. So let's go ahead and find the midpoint of EF. That's all we have to do is find the average of the x-coordinates here. So let's do that up here. And we have 2 plus 8 divided by 2, which is 10 divided by 2, which is 5. And if we do this one, we will do the y-coordinates here. So we'll have -2 plus -8 over 2. -2 minus 8 is -10 divided by 2, which is -5. So let's go ahead and write in those points. And we have, here we have 5. So this is going to be the midpoint here. And -5 is the midpoint here. And so when we draw a line segment from here to here and from here to here, that intersection will be the point of concurrency. So let's go ahead and draw in our segments. So we have one going from here through that point there, and one going from here through that point there. That looks pretty good. So it appears that our point of concurrency is right there at 4, -4. So we can say our centroid then is 4, -4. Now, let's say for the sake of discussion that this didn't look so good on our paper, and we may not be able to actually tell that it was 4, -4. In that case, we would be forced to find the equation of these two lines and find out where they intersect. So that's what we're going to do now. If you want to skip this piece, you can go ahead and skip it and move on to problem 9. But I'm going to work this through just in case you want to find out how to do it, in case you get one on a test that's not quite this straightforward. So this point is 5 and -2, and this point is 2, -5. So 2, -5. So what we're going to do is find the equation of the line through this point, from this point to this point. So let's go ahead and find the slope. So -2 minus -8 over 5 minus 2 gives us negative 2 plus 8, which is 6, over 3, which is 2. So our slope is 2 between these two lines. Alright, now let's use one of the points to find the equation of the line through those points. So I'm going to use this point, 5, negative 2. So y minus y1 is negative 2, so it's plus 2, equals m, which is our 2, times x minus x1, which is 5. And that gives us y plus 2 equals 2x minus 10, y equals 2x minus 12. So y equals 2x minus 12 is the equation of this line. So let's put that up here. Y equals 2x minus 12. Alright, let's do the next one. Let's pick a different color here, and let's go back to, let's take that one, see if we can see that. Give ourselves a little bit more room, and we're going to use these 2 points now. So our slope here is negative 2 minus negative 5 over 8 minus 2. 8 minus 2, which gives us 3 6, which is 1/2. Alright, so there's our slope. And let's go ahead and use this point then for our new line. So y minus our y1 is negative 5 equals m, which is 1/2, x minus 2. And keep going. Y plus 5 equals 1/2 x minus 2. Negative 2 times 1/2 is simply 1. So y equals 1/2 x minus 6. So there are our two equations. At this point where they intersect, both the x's and the y's are the same value. So I can replace this expression into this y. So what we have, let's go back to white, and we're going to say 1/2 x minus 6 equals 2x minus 12. I'm going to get rid of the 6's, so we have 1/2 x equals 2x minus 6. I just added 6 to both sides. We're going to multiply everything by 2 to get rid of that 2 in the denominator. So x equals 4x minus 12. And then we're going to put our x values over here. So negative 3x equals negative 12 divided by negative 3, x equals 4. And we can see that we've got the same x coordinate here. And so now we can substitute that into either one of these equations, and we can say y equals, we'll use this one, 2 times 4 minus 12, that's a 2, which is 8 minus 12, which is negative 4. And so we come out with 4, negative 4 for our coordinates, which in fact matches what we got for our centroid, 4, negative 4. Now on to problem 9.